We have a natural number, a whole number, we have an integer, we have a rational, and we have an irrational set to our number system. We're going to figure out the numbers below. Where do they belong? Do they belong to more than one? So we'll start with 3/5. Now, we already know that 3/5 can be written as a fraction, and anything that can be written as a fraction is going to be classified as a rational number, because it will have either a terminating decimal or a repeating decimal. As far as integers, whole numbers, or natural numbers goes, they don't belong to any of those sets because now it's a fraction. So we've got 3/5 is going to be a rational number. If I have 0.217 repeating, I could rewrite that as 0.21777777777, and so on. And I can see that I have a repeating number going on with that 7. So anytime I have repeating, I classify it as a rational number. And very similarly to 3/5, it is a decimal number, therefore it cannot be classified as an integer, a whole, or a natural. But -6 is a little bit more interesting. -6 has no decimal number, so we know that it is a terminating, if you would like to call it a terminating decimal, so we know it classifies as a rational instead of an irrational. But this is actually also classified as an integer. Because I've got that negative sign in front and it's a whole number, or that negative with no decimal number or no fraction number, we can actually call this as an integer. So it belongs to both sets, a rational as well as its smaller subset, an integer. So we're going to put integer next to that one. 41,275 is an even more interesting number. Now, first of all, it doesn't have any decimals, so we can say that this is terminating. So it's definitely a rational, not an irrational. We could call this a positive number or a positive whole number, therefore it could be classified as an integer. It is definitely a whole number, no fractions, no decimals whatsoever, and no negative signs, so we can even go further back. And because it's not 0, it could actually be classified as a natural number as well. So 41,275 is actually classified as all of these number systems. So if we were to put it into its set, or its smallest home set, it would be a natural number. Three multiplied by the square root of 2, a little bit trickier. So first of all, we're going to change it into a decimal, and that turns into 4.2426406877. And we can see there's only one classification for this one. It's actually a little bit easier because it is non-terminating and non-repeating. This is an irrational number. Okay. 6 pi. Now we know that pi is the most famous irrational number on the planet, 3.14159 something 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 something. And there's actually computers right now to this day calculating the next digit of pi, and there is no pattern, and it still has not stopped. You could put it on a piece of paper and wrap it around the world over and over and over again if they actually finally found those digits. So multiplying it by 6 does not make it anything different than an irrational number. If you really must know, you can take 6 and you can multiply it by pi into your calculator, and you can start to see this irrationality to it. 18.849. Ooh, look, there's 3 5s in a row, and then that pattern stops, and we have no idea what comes next. So this is going to be an irrational number. -2 1/4, you are more than welcome to change this into a decimal. You could change this into a top-heavy fraction. We could rewrite this as negative, let's say 2.25, because I know a quarter is the same thing as 0.25. And so in this particular case, it looks like we want to classify it as an integer because it has a negative sign, but we can't, because an integer actual classification is only whole numbers, either positive or negative. In this particular case, this is written as a fraction or a terminating decimal, so it is simply a rational number. The cube root of 8 is a number multiplied by itself 3 times. You can put that into your calculator, or hopefully you recognize the cube root of 8 is 2. I haven't done too much work with the perfect cube list, but that's one of them on there. And so I get 2. And so although it looks like it could be pretty ugly if we didn't really know what the cube root of 8 was, it actually turns out to be quite a nice number, and we can classify this definitely as a rational number, as a positive 2, which is an integer, as 2 itself, which is a whole number, but because it's not 0, we could also classify that as a natural number. We definitely recognize 121 from our perfect squares list. That is going to be 11. I know that's the 11th perfect square, or 11 times 11 is 121. And again, very similar to 2 itself, it is definitely a rational. You can call it a positive 11, therefore it's an integer. It is a whole number at 11, but it is also a natural number because it's not 0. Next we have 6.121, 121, ... and I see a pattern that repeats itself of 121, 121. So if I have a repeating decimal, that's perfect. I know it's going to be rational. I know that because it's got decimal numbers here, it cannot go any further down the list into integer, whole number, or natural. So we have a rational number.